Okay, so in this video we're going to show you how to calculate mechanical advantage for pulleys. Now here's a basic pulley. A pulley is just a grooved wheel that a chain or a strand or a rope or a cable can slide through. And you can see here's a very simple pulley system. This is called a fixed pulley right here. And that's because this pulley, even though it rotates around, does not move up or down. So fixed pulleys rotate, but they don't move up and down. And that's going to be really important because we need to understand movable pulleys in order to do mechanical advantage calculations. Now, fixed pulleys will allow us to transfer the force, so we can actually pull down. It allows us to turn the force down, so we can pull down to lift something up. So this is our effort force, and this is our load force. And so we can overcome our load force by pulling down instead of pulling up. So this allows us to change the direction with which we pull. But it doesn't give us a mechanical advantage. To get a mechanical advantage, we need to have a movable pulley. And we've got a movable pulley here in this setup. So this is the movable pulley. So the first thing we want to do is we want to define the pulleys. So this is a fixed pulley, and this one's movable. And so if we pull on this string cable, this pulley here will move up. So it is a movable pulley, and we calculate the mechanical advantage by adding the number of ropes supporting each movable pulley. So we've got 1, 2, so then our mechanical advantage equals 2. And you may say, well, how does that help us? Well, we can say, remember we said that our effort force equaled our resistance force, or our load force. So this is our load force, and this is our effort force over here. Our effort force equals our load force divided by the mechanical advantage, which is 2. So let's take our load force and say it's 100 newtons. And now we can figure out what our effort force is. So we can just plug it right in. So we got 100 newtons, and we're going to divide that by 2. So that means that our effort force is 50 newtons. So this would be 50 newtons of force. So the mechanical advantage of this system is 2. And that means that the amount of force we have to apply is half of what the weight is that we're lifting. Now, of course, that means we still have to. That means we're going to have to pull more cable in order for that to in order for us to lift this weight. And so remember, work equals force times displacement. And so, in order for us to do the same amount of work, if we are decreasing the force, we have to increase the displacement. Otherwise, the amount of work will change and energy won't be conserved. So that's a really important concept there. All right, so let's go to the next one and see if we can do one with more pulleys, a little bit more complexity. Okay, so wow, this one's crazy. It's got a lot of pulleys. All right, so don't stress when you see a problem like this. It's really simple. All you need to do is figure out which ones are the movable pulleys. So these guys are the movable. They're the ones attached to the load. They're the ones that can move up and down. They can move in this direction. Remember, all the pulleys can move around like that. So let's figure out the fixed pulleys. So this one's fixed, this one's fixed, this one's fixed. This is movable 1, movable 2, movable 3. Okay, so we have 3 movable pulleys. That means we have 1. I'll just go ahead and write that 1, 2, 3, 4, 5, 6 strands attached to movable pulleys. So our mechanical advantage equals 6. All right, so if we want to do our calculations, remember we can say that our effort force, which is here, has to equal our load force, and this is our load, divided by our mechanical advantage, which is in this situation is 6. Okay, so let's say our load is 10 newtons. What is the effort force that we need? Well, if our load force is 10 newtons, so we can then say 10 newtons And then what we need to do is we need to divide 10 newtons by 6. So we can say 10 divided by 6 equals 1.66 repeating. So our effort force, and that's newtons, and our effort force equals 1.66 repeating newtons in this system. We can also flip it around. We can calculate the load if we know the effort. So let's say in this system we're going to put in 100 newtons of effort. So let's just plug that right into the same equation. So we've 100 newtons equals LF, which is our load force, divided by 6. Well, we can multiply by 6 on this side, cancel that out, multiply by 6 on this side. And so that's going to be 600 newtons that we can lift with this system. Now, of course, that means that we are going to have to pull the cord or cable or strand. We're going to have to pull that 6 times as far. So we're going to have to pull a whole lot of that. But this is really handy because things like cranes, for example, they could have huge motors to lift the kind of loads that they lift, or they could take advantage of simple machines. So they could have a smaller motor that can't lift quite as much. Let's say a motor that can lift, maybe 100 newtons. But that motor can wind up as much string as it wants on its spool. So it can wind up all of that extra 6 times string and lift loads that are way more heavy than it could normally lift without the simple machine. And that's why we use these things. Okay, so you may also see another pulley problem that looks like this. It's a block and tackle pulley. If you see this, don't stress out. I know it looks really complicated, but it's the same thing. So again, we're going to count the strands for the movable pulleys. So the first thing we need to do is figure out which pulleys are fixed and which are movable. So this one's fixed, fixed, and fixed. How do we know? They're all connected to this beam up here at the top. So they will rotate. Again, they'll rotate, but they're not going to move up and down. These pulleys, because they're connected to the load, they have to move up and down in order for us to raise the load. So there's 1, 2, 3 movable pulleys. So that means that we have 1, 2, 3, 4, 5, 6 strands. 6 strands connected to our movable pulleys. And so that means that our mechanical advantage equals 6. Now keep in mind that you can also just look at the number of pulleys and count up and multiply by 2 and count up the mechanical advantage. You can just say, well, we have 3 pulleys, and every pulley is going to need at least 2 strands, or is going to need 2 strands, so it's going to be 3 times 2 equals 6, and that's your mechanical advantage. So let's do a problem with this one as well. And remember, we want to say our effort force equals our load force divided by our mechanical advantage. Okay, so let's say that our effort force is 500 newtons. How much can we lift with this block and tackle system? How much can we lift? We lift using this system. I'll give you just a second to see if you can figure that out. How much can we lift? Okay. Have you figured it out? Well, we're going to take 500 and we're going to say 500 equals our LF. So we don't know what the load force that we can lift is, but we know what our mechanical advantage is. It's 6. So what we can do is we can multiply, so we're dividing by 6, so we can multiply by 6, cancel that out. So that's going to be 500 times 6. So 500 times 6 equals 3,000. 3,000, and that's 500 newtons. Don't forget to include those units there. So 3,000 newtons. So this system will let us turn 500 newtons of lifting power into 3,000 newtons of lifting power. And again, it does that by allowing us to take up more of the strand or more of the cable, and so we can lift this. It does slow the lifting process down. You get a quicker lift if you just have one pulley and you're lifting at the same rate. You can lift it very quickly, generally. But that depends on a number of things too. You can also lift this slowly. But if you have something turning at the same rate, very slowly winding up the string, it's going to go up at the same rate here as it winds up here. But in this system, because it's going through all these different things, the load will lift more slowly if it's moving at the same rate as it was over here. I hope that helps.